Welcome everybody back to episode 8 of Error Correcting Erik, where every week, of course, we go through a chapter of David Deutsch, The Beginning of Infinity. And today we're going to try to cover 2 chapters. So we're going to try to cover chapter 8, which is about infinity, and we're going to try to cover chapter 9, which is about optimism. We'll see if we can manage. If we end up rambling too long, we're going to have to split it into 2 episodes. But we're going to try to do our best.
Right.
So let's start with chapter 8, which he dives a bit into the mathematics and the technicalities of infinity.
Right.
So for me, chapter 8 was a bit more complicated. It's quite, as you described it, it's quite technical. But he gives an experimental thought on the Infinity Hotel,
right,
in which he explains how infinity works, what its properties are, and how we can think about infinity and how we can understand it a little bit better.
Right.
So I think a good section to kick off this chapter is to start with the Infinity Hotel.
Sure. I mean, maybe so. Just for those curious, the chapter is called "A Window on Infinity." So before we do that, though, I did want to. I think the preload here is that thinking about infinity is very. It's not intuitive. It's very counterintuitive to think about infinity. A lot of people struggle with it as an abstract thing, as a way of doing mathematics, for example. You and I in class in the past, we always had when we did our integrals, right? It would be like x until infinity. So we know that it works in practical situations, and we know that it can be applied solving mathematical problems. But the first person to think of an idea as infinity, I think, is a genius in their own right. And I forget if it's in this chapter or in other chapters, but I remember Deutsch writing about the fact that some mathematicians in the more Greek ancient days, they rejected the notion of infinity like as a thing in itself, and this is meant to be not merely parochial in the sense that sometimes when people say infinity, they just mean absurdly large.
Yeah.
Right. But in this case, infinity is more than absurdly large. It is literally infinite. By its own definitional meaning, I guess, in a sense. And that was rejected, I believe, by some ancient philosophers because you came too close to God then, and I may be wrong here that it wasn't an ancient philosopher, maybe it was a more modern mathematician. Anyway, it was rejected by some because to talk about infinity would be as to talk about God.
Yeah,
so
exactly.
Therefore, it was it took time before people, the culture was ready even to discuss infinity as a real thing. But then coming to your the simulation that you mentioned that he speaks about, the hotel, the Infinity Hotel, which by the way, I think we were talking about this before, I still don't fully understand, and I have to be honest, like the fun criterion or the do what you're interested in to me really applies to this book as well. And when it gets a little bit too technical, I just kind of check out. I'll read it, but I'm not going to go through the motions of, for example, we were saying that the puppy, right? How we'll get to that, how the puppy disappears, and it's not that we couldn't, in principle, try to understand why that happened, but I'm just less interested in understanding the technical nuances of like how to apply mathematics, in infinite mathematics, into practical applications.
Exactly, especially maybe if you don't view why it is useful along the way, and you don't. I don't think you have to understand exactly all of the properties and all of the thought experiments of the Infinity Hotel to continue with the rest of the book.
I don't think so.
So let's start there. So with the Infinity Hotel, as mentioned, a thought experiment to help people understand infinity a bit better, because he says, we can think about it as a mathematical equation, as a mathematical principle. But infinity, and especially the Infinity Hotel, couldn't exist in our physical universe. So imagine a hotel. It doesn't matter. I think in the book they described it as a corridor. Right. I've seen it in a different YouTube video described as an infinite height.
Right.
Yeah. So the principle is always the same. The infinity hotel is a hotel with an infinite number of rooms.
Right.
And every room has a number starting from room 1, 2, 3, and then it goes up to infinity. Yeah. So when you look into the corridor, or when you look up at the stairs or whatever, there's no end, there is no roof.
Right.
It's an infinite amount of rooms. So couldn't possibly exist in our physical universe, but as a mathematical principle or a thought experiment, it could. So the first property is that there is always room for another guest. So let's say that the infinity hotel is fully booked. So fully booked meaning there's no more room. But that's not possible in the infinity hotel. There's always more room.
Yeah.
But how do you solve that?
Right.
How do you manage? Where do you put that person?
Right.
So it is solved by, they have a public announcement system in the hotel. And when a new guest arrives, they just say, all the guests, please move to one room up.
Right.
So the person from room 1 goes to room 2, the person from room 1 million goes to 1,000,001, and that continues to infinity. So room number 1 becomes available. And there is yet again a guest or a family that can move into that room. And then the next day, the next guest comes in and they just repeat that, and they can keep on repeating that to infinity. So there is always more room in the infinity hotel. So that's the basic premise of the idea of the hotel.
Right.
And its first property.
Exactly, and it's very cheap because I think everybody needs to pay like $1 per night or something.
Exactly.
Because you can, by economies of scale, I guess you get these cheaper cheaper rooms.
Yeah. Well, the idea is there that if every guest only pays $1 per night, but you get $1,000 per night worth of value because it's a fancy room and you get complimentary champagne and fancy gifts and perfume and maybe expensive wine bottles, I don't know. Because how does that work? Because they use the money from the rooms 1 to 1,000, so you get $1,000. They use all of that money, so $1,000, to give
Thank you.
to give value to room number 1.
Right.
And then from the rooms 1001 to 2000, they take all of that money and it goes to room number 2. So because you have an infinite amount of rooms, you can supercharge it ad infinitum. So all of the guests, so you also generate an infinite amount of money and value.
Exactly. Yeah. And I think the reason for making it in a hotel setting is done precisely to bring the concept of infinity back to earth.
Exactly.
To give people like a practical example of a potential simulation. Again, as you said, that would not be physically possible in our universe, to the best of my understanding. But however, as long as your simulation is consistent, we can still use the concepts of infinity to kind of, again, bring them back down to, like, I guess what people are more used to thinking about. So like there's concepts like there's different sizes of infinity that come up. I think was it like one of Cantor's diagonal proofs as well, where he proves that there's different sizes of infinity and etc. So that's why I think I said maybe it's best to do 2 chapters because of the technicality of this chapter. And again, I don't necessarily care too much about the mathematical mechanics behind this, but I think as for the listeners, obviously it's an interesting chapter to get more familiar with thinking about infinity and applying that counterintuitive notion of, like, for example, if you told somebody, myself, if I remember hearing for the first time, one infinity can be bigger than another infinity, and you're just like, that's absurd. Right. But then there's a proof that proves it. So all these counterintuitive things that really still solve problems and still abstractly work. So maybe diving into it. I know with the puppy, for example, like the example of where the puppy disappears because of an iteration of it being handed over, or the trash as well that's being handed out. And I urge anybody that's interested in that to go into the mechanics of it, because he does touch upon a singularity, which could be similar to like a black hole singularity, out there where basically things, you know, kind of disappear from the universe, if you will, literally. So yeah, I don't know how you found that chapter in that regard, or what specifically did that chapter help you, I guess, in understanding infinity?
To help me to understand infinity a bit better, and to think about certain things that I've never thought before, that absolutely yes. Yeah. Does it contain a lot of practical stuff for the rest of the book, or let's say his thought process? Not so much for me, but I still have to read the rest of the book. But I think, the book is called Beginning of Infinity. So I think it's a good part of the book to help you to understand infinity just a little bit better. So let's briefly touch upon like 2 or 3 subjects at the Infinity Hotel, and then we'll move on, because you know, we're not gonna.
Before you do that, just a thing. It is necessary to understand that for the rest of the book, and I actually only got that when I reread it now for the 4th time. I kind of understood, and I've heard Brett Hall as well on his podcast talking about certain relationships that he didn't first understand. And then I've heard David Deutsch talk about Brett Hall's interpretation of those connections that David Deutsch didn't even mean to be there in the first place. Where he said the way that Brett was talking about what I was writing, I didn't think of it even about those 2 things being connected. So you know, not to say that this is all like, I mean, obviously it's a masterpiece and a genius thing in itself, but a lot of it's because it's a consistent whole. You will always find connections, and I think so. Coming back to the connections that I found, but you'll need to have a little bit more understanding of the concepts of the future chapters where the infinite growth of knowledge. You need to understand infinite as a concept before you can understand the infinite growth of knowledge. And what I got today, and I may be wrong, of course, we're all fallible, so it is very likely that I'm wrong, but that the example of that, you know, $1,000 in value coming back after, you know, with 1,000 rooms, you know, dollar, and then because it's infinite, you always can get it back. I don't think that's an abstract example. I think that is I think that's what actually happens. I think that's what kind of drives economies and what happens when value is created.
I see what you mean.
And when knowledge is grown, and where you can actually use value, give it to people, while still making profits. Because the Infinity Hotel in this universe is a profitable hotel. Right? Exactly. And it can give everything to everybody because of their business model. And that's what got to me today, is like, holy, you know, shit. That you know, may not make sense yet, but there's a connection here to the infinite growth of knowledge, and how money or wealth, as Deutsch, he describes it as the set of all possible transformations that you can bring about. So, for example, you know, you being able to go out and create a fire, and then, you know, rent out that fire, for example, to bystanders for $1 per hour, right? There's in principle nothing stopping you from just selling that fire over and over again, right?
Exactly.
And this can go from building houses to the modern economy that we have today to, you know, Elon Musk with his rockets, right? So they are bringing about physical transformations, and that ultimately is wealth. And money, or fiat, right, or Bitcoin or whatever, is a proxy to that ability to be able to bring about those physical transformations. That took me a while before I really understood, I guess, the critical rational implications of what money represents and what it is in reality.
I think that's a really good point, because at the end of every chapter he has a list of like his terminology as he described it, and when he talks about infinity, wealth is there as well. So that's most likely the reason why he included it.
Right. Wealth can be unlimited, can be infinite. Wealth can we can literally be wealthy ad infinitum if we just keep growing knowledge. In obviously then a society that allows for the growth of knowledge to flourish.
Exactly. I think that's an important subject for the next chapter, optimism, because there. So let's park that one for a second.
Yeah.
Briefly go over two properties
Sure.
of the Infinity Hotel,
Yeah.
and then we'll talk a bit about proofs, which was a part that I didn't fully understand.
Yes, that's a good one. Yeah.
So we'll talk about that, and then we can jump on over to optimism. So we're not going to talk about every single property of the Infinity Hotel, but one interesting one is that there are also limitations, because as you said, we can think about it in a mathematical way as long as it's consistent.
Right.
And there are things that in the Infinity Hotel that rules that we need to implement, or otherwise things will break. For example, there is also, for the infinite amount of guests, an infinite amount of staff in the hotel, cleaning rooms, making dinner, all of that stuff. And the guests, as well as the staff, they both sleep in your hotel.
Right.
So, but of course, what you cannot do is, he calls it an infinite regress, is, for example, the staff saying, "Oh, you know what? I'm not gonna clean rooms. I'm not gonna make dinner because there isn't somebody else who will do it for me." Because if everybody does that,
nobody does it. Yeah.
Then nobody does it, and then the entire whole hotel will grind to a halt.
Right.
So there are things that you can do to overload or break.
Yeah.
The properties of the Infinity Hotel, and so that's one thing. The other thing that he discussed about is that statistics and probabilities also disappear with infinity.
Right.
For example, in a book he says, David Deutsch, he wrote a previous book, The Fabric of Reality, and he says, okay, let's imagine that we hand out two books, the new book, Beginning of Infinity, and the old book, The Fabric of Reality. But to keep it a bit more simple, I think in the book they use the example of 1 in a million. Yeah. Let's do 1 in 10 to keep it simple. So only every 10th room, so the rooms number 1, 10, 20, 30, they get a copy of the new book.
Right. Yeah.
And all the others, they get a copy of the old book.
Right.
And you repeat that pattern to infinity. So you could argue, well, there are 10 times more old books than there are new books.
Right.
And if you would enter a random room, you would have roughly 1 in 10 chance to get a copy of the new book, which might be more desirable because maybe you read the old book. But because you have an infinite number of books of both, you can kind of rearrange the books.
Right.
You can make them even. You can say, through the public announcement system, everybody that has a copy of the new book, you need to put it in, you need to send it to an even numbered room, and the other one goes to the odd numbered rooms. Because you have an infinite amount of books, you can do that. So suddenly the odds are stacked 1 and 2.
Yeah.
No longer 1 in 10.
Yeah.
So now suddenly you have a 50% chance of having the old book or the new book. And you can even reverse that. Right. You can say all of the people from the rooms 100 to 1000, put all of your books in the rooms 1 to 9. And then the old book. Right. And then one copy of the new books goes to room number 10, and you keep reshuffling that. Exactly. So now you have flipped the probability of getting. So those are kind of like that was mind bending a bit.
Yeah, because it has to do with sequencing. It doesn't have to do with, and I think it touches on fine tuning and stuff, because it has to do with, certain people argue that there's some kind of the fine tuning argument, right, where there's a constant of nature, and if you tweak that constant a little bit, our universe isn't stable enough or something. Yeah. And then it goes into like, how many universes would have astrophysicists contemplating about the existence of that universe, and then what are the chances of having such a universe where an astrophysicist is alive, and if you tie that to your probability, and this has to do with the multiverse, which is a future. I think it's this book as well. Where
it's it's the next chapter after optimism. Okay, I saw it. It's chapter 10.
Okay. So once you go into multiverse, you have to understand infinite concepts. Yeah. Because it is infinite in a sense, and I think then it goes into like you have infinitely countable, and then you have like uncountable infinites as well. So there's kind of these rules about the multiverse because they need to be consistent still. That have to do so. For example, like and you reminded me of that when you were saying this, because you could rearrange the universes in such a way that you would have the first 10 astrophysicists and then a million no. Yeah. So if you would say after 10 samples, if you take a sample of 10 universes and they all had astrophysicists, you would maybe think, oh, life is everywhere.
Yeah.
But then if all the rest after that don't have life, for example, then it's still not very common to have life. So that's, I think, now that's starting to make more sense now that we're talking about this for me too, because now I'm understanding that the concept of infinity, you need to understand what that means. And because, as you said, there is no concept of probability there, because you could just kind of make it,
exactly.
match whatever it is that you'd want to prove in a sense.
Yeah, exactly. To continue with that, in the book, he has an imaginary multiverse jumping machine.
Yes,
and
exactly.
there's a button, and you can press it, and then jumps to a next universe.
Right.
And even though the universe constants there would not allow life to flourish or whatever, you're still protected, and you can measure if there are astrophysicists.
Yeah.
Because they, it's a good indicator to search for life, because as soon as you have astrophysicists, they will send out radio waves into space. And
you say, oh, I'm here.
Yeah, you can say, I'm here.
Yeah.
You can catch them, and then you can say, okay, in this universe there's intelligent life. So that's kind of his thought experiment on how to search for intelligent life on other universes, and how you can rearrange them exactly as he would rearrange the books. Yeah.
Right. Yeah, and on the proof thing, if that was next in line.
Yeah, yeah. So we're not going to talk about the puppy?
Well, I just don't know enough about. I wish the puppy was still here.
Same. just for the sake because when we talk about proof, I would like to read the last two sentences, which kind of summarizes it. But I don't really fully understand that stuff about the proof. But let's, for the sake of completeness, talk about the puppy, and then we can move on to proof.
Okay.
So, a second property of the Infinity Hotel is that there is no trash, because you can get rid of the trash.
Right.
And it goes through the public announcement system as well. So you just say, oh, everybody, pack up your trash, put it in a bag, and pass it on to the next room above you. And if you keep doing that, the trash will go infinitely high and it will completely disappear.
Right.
But he says, well, we don't want the guests higher up to have to repeat that ad infinitum. So so there is a system where you only have to do that for 2 minutes, and for the first bag of trash you have 1 minute. Then you get a new one. You have 30 seconds, and then it's halved again. So you have 15 seconds, and so on. So after 2 minutes, the time becomes infinitely shorter for you to pass on the trash bag, but still, it is finite. So you can have a finite amount of time and a finite amount of actions, and then still the trash can be moved up infinitely. Yeah. And that's something that I couldn't fully grasp, and I think it has something to do with something that we discussed before. If you have 1 minute point 9999999, and the 9999 continues forever, and it is infinitely small, then it's basically the same as 2. And there's mathematical proof that 0.9999 and so on exactly equals 1. So that's kind of, I don't fully grasp that, but let's assume it's true, because it has been proven that you can infinitely get your trash away. And then he says, well, by accident, somebody has a puppy, and the puppy jumps in the trash bag, and you pass on the puppy infinitely high, and the puppy is gone. And then the guest is, of course, oh, I want my puppy back. And then they try to get the puppy back, and it's the weird stuff, through the public announcement system, and by saying, oh, can you please move the trash bags back down? But that's not possible.
Right.
Because apparently, if you move them infinitely up, they are out of the
universe.
They are, as they described in the book, nowhere. Yeah. They're not somewhere, because even though you've only been passing them on for 2 minutes, they're completely gone. So there's no way the puppy can come back.
Right.
But that's something, so why exactly does it disappear? That's something that we both have difficulties, I think, understanding.
Yeah, and it's for context, the puppy is accidentally given in the trash, and the trash is being moved, and an item of value has been also passed on accidentally, and then they call and they say, oh, sorry guys, everybody bring X amount back, because there's an item that a guest wants returned, but that's literally not possible. It's physically not, or I don't know, physically, it's not possible within the rules of the universe.
Exactly. In the rules that were set for the Infinity Hotel, you could argue that the puppy just disappears out of nowhere and suddenly it's just back.
Yeah.
And then he talks a bit about the Big Bang and universes appearing out of nowhere, which then could be related.
Yeah. Because it has to do with infinity, and that's because infinity is such a counterintuitive thing.
Yeah.
That's why he brings it back to an hotel example, because once you go into stars and black holes, then the average Joe like us, kind of gets lost, and we even get lost when they talk about hotels.
Yeah, exactly. So imagine black holes where even laws of physics would break, we don't know, or mathematics would break, we don't know.
Right.
So for those who are listening and that can explain why the puppy exactly disappears,
please reach out.
I think it would really help us to understand a bit better how you can get rid of the trash and as an item or the puppy in just 2 minutes, because in my understanding you would have to pass on the trash bags infinitely faster and faster, which then kind of breaks like the rules, because he says that in the book. We don't want people to move an infinite amount of trash bags, and they don't have to do that infinitesimally small. But then how? I don't know. Some probably smarter person as us would explain it.
More interested person.
Yes, absolutely. Let's call it like that. Yeah.
So
let's move on to the last section of the book, proof. And I thought it wasn't important, but you said it was.
Yeah.
So I'm very interested to hear what you have to say. So I'm just gonna read 2 sentences of the summary. And that should be enough to be up to speed about his views on proof. So proof is a physical process. Whether a mathematical proposition is provable or unprovable, decidable or undecidable, depends on the law of physics, which determine which abstract entities and relationships are modeled by physical objects. Similarly, whether a task or pattern is simple or complex depends on what the laws of physics are. So when I read that, I kind of understand what he means, but I don't grasp yet why that principle of proof, because he talks a lot about proof in this chapter, is important.
And you've also mentioned it a couple of times throughout this conversation.
True.
While you then say it's actually maybe not so important. So
true.
I find it a bit paradoxical that you would just an
true.
observation.
Yeah.
So proof is important because and as you say, it is a physical process. So proof is a computation, such as the 2 + 2 is a computation. Proving 2 + 2 is 4, and that proof is also a computation. So you have, and interestingly enough, if other people are interested, I'm reading the book The Journey to the Edge of Reason, the life of Kurt Gödel, who is the mathematician that basically proved that there are they call it the incompleteness theorem of Gödel.
Okay.
And you touched upon that in your sentence there that you read out about decidable and completeness or incompleteness. So basically, for a system of logic beyond basic logic, which is and or, which is complete and decidable, I believe, any like multi-complex logical system or framework, which is anything with like multiple integers, like 1, 2, 3, 4, and plus minus, multiplication, can provide you with output. So you have input of a, like 2 + 2 is an input. The output is 4. Right. So that's provable. And what Gödel proved is that any such system is incomplete. And I believe it is decidable, but you can never know. So practically this means that your framework, your mathematical framework, will produce results that are true per the system, but not provably true. So a really cool example that's often cited is like the twin prime conjecture. I don't know if you've heard about that, but basically if you would plot on an x-axis 0, 1, 2, 3, 4, 5, at infinitum, prime numbers pop up, right? And for context, prime numbers are only divisible by 1 or themselves.
Yeah.
Yeah. So the first one we hit is 3, right? And we have 7. So and so forth. So if you would plot it out and you kind of zoom out, and you should look on this on Google. It's quite interesting to see. Prime numbers they pop up in twins, always for 2.
Okay.
So always like 2, relatively short with each other.
Yeah.
And then you've got none, super long, and then poof, you got 2 again.
Okay, cool.
And then again, you've got a lot of not primes.
Yeah.
And this is only obviously with whole numbers, right? Whole natural numbers.
Like maybe like 101 and then 103, which are.
I don't know if that's a prime or not. I don't know. It could be. Is that a prime? Are you sure?
101. Yeah. Or it could be. I think it's a prime number. Yeah.
Oh, yeah. No, sorry if I'm wrong on this.
Yeah.
But yeah, so you would indeed have they would pop up in twins.
Yeah.
So the conjecture goes that there's an infinite amount of prime numbers, and the twin, let's say, relationship also maintains ad infinitum.
Yeah.
Because there's an infinite amount of natural numbers.
Of course. Yeah.
So,
I understand.
like the logical extrapolation is there's an infinite amount of prime numbers.
Yeah.
And not only primes, but the twin prime conjecture says that they then kind of show up in that twin pair relationship. But so far, nobody in mathematics has been able to prove this.
Okay. Yeah.
It has not been proved yet.
Yeah.
Which brings me to the incompleteness theorem of Gödel. It's not necessarily provable.
Yeah.
At all.
Yeah. That would be my first logical question, but I think I already know the answer. Some truths, like that one, might not be provable.
Exactly. So you could be staring at a true thing,
which is not provable.
Which per the system itself isn't provable.
Okay, I see. Yeah.
And that's what Gödel proved.
And that's his incompleteness theorem.
Incompleteness theorem.
Okay, interesting. Yeah.
And the other thing is you have to have a decidable outcome, which means, and I'm not entirely grasping this yet, but I think I'm in the neighborhood. Whenever a result is given, it always needs to be that and not that. So, for example, it needs to be 4 and not -4.
Yeah.
Okay. Or it needs to be A, not -A.
Yeah.
That means it needs to be decidable, because if you could have multiple outputs, right? If the input gives you 2 potential options, then it's not decidable.
Like the square root of 4 is 2 or -2.
Right, could be. Yeah, I don't understand that yet. If that, but it sounds
something like that. Yeah,
it sounds like that. But so a system needs to be decidable or undecidable, and then again, Gödel proves the decidability and the incompleteness. And maybe it's undecidable. The decidable part, I've just started to grasp, but the completeness or incompleteness part, I've kind of have a good grasp about. So it is important, because anything you're going to do through a system, which is basically anything, any science, right? Any physics, any chemistry, any mathematics, any abstract use of concepts is a framework. So people thought in the early days of mathematics, like, oh, we've got the bedrock, the Pythagoras school of thoughts. They thought that everything was lines and triangles, right? So they literally thought the world was based out of mathematical equations, almost, geometrical structures, which has been debunked as well because of Einstein's relativity theory, where the sum of a triangle
is more than 180.
Can be more than 180 or less or whatever, because of the space-time
because you can warp it, and it's no longer flat Euclidean space.
Exactly.
And it's the curved space, and then
it's
a triangle is no longer a geometric triangle as we understand it. Yeah.
Exactly.
Okay.
So, and that's also a framework, right? So, so what Gödel proved is, you can look at something completely true, but you can never prove it.
Okay, I understand. Yeah.
So, but it was important for I think the philosophy of mathematics to kind of get out of its high horse. That it had this objective reach to knowledge. Which they don't. It's solving problems, same as other problems are soluble. Obviously, if it works, it still works. Like you don't need to be able to prove it for it to be practically, applicable to everyday, problem solving type stuff, right? But it is one of the most groundbreaking discoveries of recent mathematical history, where he basically proved that some things are non-provable within the system. And also Popper has a really cool book that I read, The Myth of the Framework, where he also describes logical inconsistencies and stuff, where like the rules of logic are, you have, maybe sort of derailing a little bit, but for example, you have the law of the excluded middle. You have the law of consistency, something
that's described in the book.
Yeah. So the law of the excluded middle is that something cannot be that thing and not that thing, which is similar to what we said, right? Something cannot, to be decidable, it needs to be either or. It cannot be both. And that is also the law of logic. You have a couple of laws. I think there's 2 or 3 main laws, where you cannot have something cannot be both A and minus A. Like your cat cannot be a dog.
Yeah, exactly.
For example.
Okay. Okay. Yeah. What you say that there's one more interesting part about that in the book, I believe, because what you say that the mathematician, they uphold like, we have the highest truth. The universe is just math. I think that he describes, if I understood it correctly, that other experts in other fields of expertise also consider that. So a evolutionist would see the signature of evolution as Deutsch describe it everywhere and uphold that as the truth. A cosmologist would have something else, maybe energy fields, whatever.
Right. Yeah. I mean, I think we're all kind of biased or prone to see the world through our specific scope of expertise. I think that's normal, because if you're looking at a type of thing every day, let's say you're a horse rider, like you will see things analogous to horseback riding or something. I'm giving just a very parochial example. But I think the mathematicians themselves are really on an extra level of, I want to say delusion. So, and he has a really cool, and I think it's in this book as well, the mathematician's misconception. He has a whole chapter devoted to basically talking about how mathematics is not some special realm of truth. It is as fallible of knowledge as any other type of knowledge.
It's a later chapter then.
Yes.
Okay, cool.
And it's one of my most favorite chapters.
Okay.
He basically kind of bursts the bubble of the mathematician thinking that they do deal with actual truth, capital T.
Yeah.
Like, because physics, it's always like, but we'll discover something else next time, and maybe the sun is now that circumference, and maybe we have a new law that we discovered and it changes a little bit, right? Mathematicians think they have this realm of static truths.
I understand.
Of kind of infallible truths, or at least that's how they kind of sometimes conduct themselves.
I understand.
That they don't have to deal with the
error correcting philosophy.
The earthly things. Right?
I understand.
Yeah.
Okay. Interesting. Looking forward to read it on that one. Before we continue to chapter 9, optimism, anything else that we need to close off on infinity?
No, just the concepts of completeness and incompleteness and decidability took me a very long time, and I'm still not fully grasping it, so apologies if I'm not getting this entirely right. But that is fascinating. Like, once you grasp that systems are fallible, and mathematics is a system, it's fallible, as well as just like reading up into Gödel and Cantor's equations, and you don't, again, like and we started this session off saying, to me, that's the less interesting part. I'm more interested in the philosophical implications, what Gödel proved, rather than understanding how he proved it.
Exactly. Okay, cool.